But welcome. Thank you so much for joining us today. We have a really good presentation planned for you. Before we get started, just a couple housekeeping things I wanted to make sure everyone is aware of. First is, if you have a question throughout the webinar, there's a questions tab on your screen, so you can just put your questions in there. We have a Q&A session at the end, so we'll try to get to everyone's questions at that time. And secondly, the webinar is being recorded, so if you want to watch it later, share it with someone. It's going to be provided in an email a little bit later today, and then it will also be available on our website. So with that, I want to introduce myself. My name is Jennifer Bonzani. I'm going to be your host today. I am an aquatic specialist and business development consultant with Solitude, of course. I have been with the company for a little over 4 years. I'm out of our St. Louis market. And then we also have Shannon Jr. joining us today. Shannon has worked in the lake and pond management industry for over 20 years. Right now, she is an aquatic ecologist and our senior business development consultant. She is out of our Virginia office. As one of our top experts, Shannon manages several projects of all facets of lake management, including nutrient remediation. She has her Bachelor of Science in Biology and a Master's degree in Environmental Science and Public Policy from George Mason University. And she's involved in several industry organizations and is on the leadership team as editor for Women of Aquatics. And then next up is Dominic Maringolo. He is an environmental engineer and project manager with Solitude, and he is based in our New England office. He has more than 25 years of lake and pond management experience and is responsible for leading our large in-lake phosphorus management projects. He has an extensive background in the implementation of a wide variety of management techniques and uses that knowledge and expertise to work on expanding services for our clients across the country. Dominic has his Master of Science degree in Environmental Engineering from Worcester Polytechnic Institute. He's also an active member of several industry organizations and has presented at events for many aquatic plant and lake management societies. So we're going to hear from them in just a little bit, but let's go ahead and get started. And we'll go over the agenda of what we're going to be talking about today. So the first thing we're going to talk about is the benefits of pond nutrients. They're not all bad. The next is what the impacts of excess nutrients are. We'll also cover what the sources of nutrients can be. We'll go into what nutrient remediation is, what it means. We'll look at 4 different solutions, and we also have 2 really great case studies for you, one in Arizona and one in Vermont. Then we'll go into, how to figure out what the best solution for your pond is, how to get that started. We'll also talk about an integrated management approach, what that looks like for you specifically, and then we'll go into the Q&A at the end. But with that, I'm going to go ahead and hand it off to Shannon. She's going to start us off with the benefits of pond nutrients.
Thanks, Jennifer. So yes, nutrients aren't all bad. They do have somewhat of a bad rap for causing water quality impacts, but they're actually the base of the food chain, and they provide sustenance for all of the plants and animals in the aquatic ecosystem. When there are healthy levels of nutrients, then the ecosystem will be balanced and thriving. But when there's excessive levels of nutrients, that's when water quality problems develop. So as the health and the aesthetic integrity of a water body becomes compromised, that's when it becomes more prone to weed and algae issues. But what causes those nutrient imbalances? Nitrogen and phosphorus exist naturally in every water body, but there are a lot of external sources that can cause nutrient levels to become excessive. So nutrients are constantly being delivered to ponds and lakes from the watershed, and a lot of those sources are outlined on the slide. Every time it rains, that stormwater runoff flows into our waterways, and it brings with it fertilizer, eroded sediment, animal waste, and a lot of other pollutants. And things can also be blown into the pond or a lake. So say every fall when the leaves fall off the trees, those make their way into the pond, or grass clippings can get their way into a pond. And, you know, I guess a lot of those things we have control over. So if it's on our property, we can rake up our leaves, or we cannot mow all the way to the edge of the pond. Or if we live in an HOA community, we can coach our residents on responsible fertilizer practices. But a lot of the sources are actually outside of our control because they're coming in from outside of our property from the larger watershed. But why does that matter? The problem is that over time, those substances build up as sludge or muck in a pond. So you basically end up with a big compost pile on the bottom of the water body that can feed nutrients into the water column. So all of the ponds shown on this slide are exhibiting symptoms of nutrient enrichment. And while we do have short-term treatment strategies that can kill weeds or algae, the better approach for the overall health of the water body would be to develop a long-term nutrient management program, and the ultimate goal would be water quality improvement. There's a lot of different ways to improve water quality, but today we're going to discuss specifically nutrient remediation. So what is nutrient remediation? Essentially, it's the practice of binding phosphorus and nitrogen to minimize water quality imbalances. Water bodies that have healthy levels of nutrients, they tend to be in better shape, and they are less conducive to the symptoms that we saw in the last slide. Nutrient remediation strategies also can help slow down the aging process of a pond. So if you've heard the term eutrophication, ponds and lakes that have lower levels of nutrients are lower on that trophic scale, and that's generally considered to be healthier. It's important to note, though, that none of the strategies that we're discussing today should be considered direct treatments for a weed or algae bloom. It would be more analogous to, say, for humans, if we eat less saturated fat or if we exercise, then we're going to be less susceptible to conditions like heart disease or diabetes or something like that. We'll live longer. And, you know, our physician might prescribe those behaviors to improve our overall health, but if we have a serious medical condition, running is not going to be, you know, the first thing that they recommend. So kind of in that same way, nutrient remediation can make a water body healthier and more well-balanced, but it's not going to be the prescription if you have a, you know, serious problem like, say, an algae bloom. We're going to talk today about 4 different strategies for nutrient remediation, and I'm going to turn it over to Dom now, and he's going to start the discussion.
Thank you, Shannon, and hi, everybody. Thank you for taking the time to spend an hour with us today. So now that we know, have an understanding about nutrients, excess nutrients, and the causes and effects of that, I'd like to go into some of the common techniques that we as water resource managers can use to address those nutrients. And, you know, by and large, for me, nutrient remediation projects that we've done have been very exciting. We've had a lot of great success stories, improving nutrient levels and water quality for a longer term, and had very good success with many lakes, improving water quality and ultimately preventing nuisance algae blooms in the long run. They're proactive too, which is great. We always like to try to use proactive methodologies rather than reactive, and these types of nutrient remediation solutions are really getting into that proactive approach. So we have nutrients. We talked a little bit about the nutrients coming in from the watershed, and certainly Many of you that are familiar with the watershed, their watershed management, trying to reduce those sources before they even get to the lakes and ponds is important. But we're gonna definitely something that should be addressed. But a lot of times, or watershed management cannot do quite enough or not do things quickly enough. And additionally, a lot of those nutrients that have come into the lakes and ponds over the decades prior to this are still there, and there's still another source that can kind of recycle through the lake and pond too. So those need to be addressed as well. And typically that requires in-lake management. So again, I'm going to talk about 4 items. I'm going to talk about the first 2. So the first technique we're going to talk about is Foslock. So Foslock was actually developed in Australia and was started to be marketed in other parts of the country around 2010. Foslock is a modified clay, which actually has been, which contains lanthanum. Lanthanum is a metal, and it's embedded in that clay carrier. The lanthanum is really what does the work here. Lanthanum has a high affinity to bind with dissolved phosphorus, free reactive phosphorus. As you can see in the diagram here, the Foslock is applied, settles down through the water column, capturing that free reactive phosphorus, and then settling it down to the bottom. So again, Foslock is a clay carrier. It's a granule. So it can be applied directly as a granule in certain situations, but a majority of the time, we're taking that clay material and mixing it with pond or lake water into a slurry, and then applying that slurry to the lake. As you can see from here in these pictures, some different methodologies of creating that slurry and applying that. It can be applied to the whole lake. It can be applied to sections of the lake. And it works really well, again, on capturing and binding with that free reactive phosphorus. Again, it's important. The Foslock does not alter any other aspects of water quality. It's pretty benign. It's a clay carrier, so the lanthanum settles through the water, binds with the phosphorus, and then is settled down onto the bottom of the lake. It can address at lower doses of Foslock. It's mainly for stripping the water column. At higher doses, we can put enough of this Foslock on the bottom of the pond or lake to also inactivate that legacy phosphorus, or those nutrients that have been in there for many decades, and that would potentially be released into the water column. In terms of dosing, it's very important to have a professional applicator conduct the work. It's also important to have testing done beforehand and to know exactly how much phosphorus that you have in your lake and pond or in the water and the sediment to properly design this type of a treatment. So having a professional and having some water testing is very important. Just to kind of illustrate the successes of Foslock, we have a case study here. This community pond is located in Arizona. The water quality was pretty poor. It had for those of you who are familiar or like numbers, 122 micrograms per liter of phosphorus in the water, which is very high. It's about 4 to 5 times higher than what we'd really like to see in the water column. They also had a very rare type of toxic algae, and you can see some of the issues here that this pond has had. So the algae was controlled through a maintenance program. So we use registered algicides to control the algae. Typically with Foslock and with alum, as we'll talk about later, it's best done when there's not a lot of algae biomass in the lakes and ponds. So typically that would be spring or fall, but can also be done in the summer if the pond is pre-treated with an algicide. So this treatment was conducted with Foslock. We also at the same time put a non-toxic dye into this water body. But post-treatment, The water quality was greatly improved. We had a 75% reduction of total phosphorus in this pond. We also saw increases in DO levels from the absence of algae settling down to the bottom and decomposing. So the Foslock treatment really worked well to improve the water quality, reduce phosphorus levels, which in turn kind of limited the amount of food that algae had to grow. We saw much improved results. We did not see a return of that rare toxic algae that was there as well. So this is a really an example that we've seen over and over again at many lakes, and it really works. It really works well. Dosing rates can range from 100 pounds an acre up to really thousands of pounds an acre, depending on the amount of phosphorus and depending on whether we're looking to treat or whether we're looking to kind of affect the water column or the water column and the sediment. So that's Foslock. We're going to move on now to alum. So alum has been around for a long time. Really, there's reports of it being used for 100+ years in water treatment industry, wastewater treatment industry. That's really where this product originated from. It's aluminum sulfate. The aluminum is actually what does the real work here that we're looking for. It's the aluminum is the one that binds with the phosphorus. So again, it's been used in wastewater and water industries. The alum, actually, when it's applied to the water, forms a flock. So it precipitates out of the water into the snowflake-like flock, which you can see in the picture here. And that's what settles down through the water. So it's just similar to the lanthanum in Foslock, but here in alum we have aluminum. It's just a different type of metal that's doing that. So in terms of methods of application, you know, you see here in this picture, and we'll have a video a little bit later, but this can be applied to small ponds. It can be applied to large reservoirs. It's applied from boats. We have a barge that it's also used there as well. The alum, unlike Foslock, alum can address as well, you know, water column as well as sediments, depending on the dose. The extra benefit really of alum here is that it's also a coagulant, and it flocks out suspended material as well. So where lanthanum is more focused on dissolved free reactive phosphorus, alum can also do that, but in addition, it can settle out some of the solids that may have more complex phosphorus containing materials as well as suspended sediments. You can see here on the right, the set of picture on the right of the fountain. Obviously at that pond we had some pretty severely turbid water going through that fountain. It was treated with alum, and you can see that the turbidity drops off there. Very great. We have nice clear water now. So alum can provide that additional benefit of water clarification. So we have a video, and this video has some footage from projects in Maine and Cape Cod. There's if you have some problems with your audio, it's okay. You know, there's just some background music here. There's no speaking, but we'll talk a little bit about this. And this is our alum treatment barge that's used here. Great. So in that video, you can see one of our alum barges. So alum, when it's applied to water, the reaction that forms that flock or that snowflake causes the pH to go down. So in many situations, we have to also apply a buffer, especially at the higher doses, higher dose projects. Typically, that product would be sodium aluminate, but there are other buffers. The benefit with sodium aluminate is that it also contributes aluminum to the treatment and actually works with the alum to form additional flocks. So it provides some buffering capacity as well as contributing to the dose. The quantities here you saw in the video, a tanker trailer. I mean, depending on the dose, whether we're doing water column stripping or a higher dose trying to inactivate bottom sediments, we can be talking about tens of thousands of gallons, even on some of the larger lakes, hundreds of thousands of gallons of this product. And so typically the lake is broken up into sectors. The barge or the boat is GPS guided for the operator to stay within treatment areas, and it's usually broken up into different areas to systematically conduct the treatment. So we're going to move into an alum case study. So this particular project was up in Vermont. This project was really great because this was part of a really long-term project for this lake. They had done a lot of work with watershed. We talked about that at the beginning, how that's important in many cases. So they did a lot of work in the watershed, cleaned that up a lot, and the last piece of the puzzle really was addressing that legacy phosphorus in the sediments, and we were contracted to conduct that treatment to put that final piece of the puzzle in there and finish off that restoration project for the state. So as we said, a clarifier as well as a nutrient binder. You can see before we started the treatment, we have a water clarity by Secchi disc of 2 to 3, for about 2 to 3 meters. After the treatment, we saw a pretty steady improvement in that water clarity, which is great. And they also saw, with post-treatment testing, very low very low phosphorus levels, both at the surface and at the bottom of the lake. So it still continues to be a success. Just to get a little bit more into the pH, we talked a little bit about the pH and what alum can do to the pH, the potential need for a buffer. Alum works best at a certain pH range, and that pH range is really between 6 and 8 units. When we arrived at this lake for treatment, the pH was actually up in the 9 and 9.5 range, likely due to an algae bloom that had been going on there and the photosynthetic process causing that pH to go up. So working with the project partners, we had to kind of manipulate the buffer and alum ratio a little bit to bring our pH down into the desirable range. And then we continued to kind of modify that ratio of buffer to alum to make sure that the treatment worked safely. And that working with the project partners, that worked out very well. The regulators and the client was very happy with how that went. Clarity, just another example. We were fortunate enough to have one of the residents on this lake take a sample in a wine glass here, just to kind of show you explicitly how water clarity improved before and after the treatment there. So just another quick note on, so these are generally, in-lake treatments, Foslock and alum. They act very similarly. They both have their pros and cons, so it's important to really plan and design which product's right for your lake and what the proper dose is. Alum, just kind of leading into Shannon's piece coming up here, alum more recently has been used as well in dosing stations to treat incoming water, either from storm drains or streams, to kind of continuously remove phosphorus from the incoming water. So that's kind of a newer use of that. It's been around probably for 10 or 20 years, but we're starting to see more of that being done, and that's definitely a good additional tool here for the use of alum. So that's those two. I'm going to turn this over to Shannon, who will cover the last two techniques today.
Okay, thanks, Dominic. Dom had talked a little bit about using alum in flowing water, and the next tool that we're going to talk about is also used in flowing water, but it's actually a nutrient filtration technique that removes contaminants from the water. There are two primary products that we use for this type of tool, and they both work in a similar fashion. We put the products in these bags or socks, and they can be anchored near the pond inflow or in other flowing water areas, and then the water is actually filtered by the media as it flows through the sock. So one of the products is called biochar, and it's derived from wood. It has similar characteristics to activated charcoal, like what you would find in a drinking water filter pitcher or in your fish tank filter. It removes nutrients and metals and other pollutants from the water. The other product is called Utrizorb, and it actually contains a substance that is very specific to binding phosphorus. So it's really geared towards more targeted nutrient removal goals. In both cases, the socks do need to be replaced periodically because the binding sites become full on the media. And when that happens, you can actually use the media as a terrestrial fertilizer. So it could be spread out in a garden or a planting bed and could actually have a beneficial use after it has done its nutrient remediation work. The next strategy that we're going to talk about is biological water quality augmentation. So bioaugmentation refers to using bacteria for water quality improvement. And much like nutrients, beneficial bacteria, they occur naturally in ponds and lakes, and they're the microbes that are responsible for processing dead organic matter. The bacteria convert nutrients into forms that aren't available for use by algae to form blooms, and they promote decomposition, and they also prevent organic matter from building up in a water body. And biochemists have found ways to culture those bacteria so that we can add them to ponds and lakes for water quality improvement. It's kind of analogous to how humans and pets, how we use probiotics to promote digestion. So probiotics are sort of, the beneficial bacteria products are sort of like probiotics for a pond. The bacteria in ponds also can become part of the food chain. So the bacteria can become a source of food for zooplankton or for other small organisms. It's important to note for bioaugmentation that it's not a fast process. We're not going to see instantaneous results. So we would need to think more on the time frame of weeks or months versus hours or days. So there is kind of a time lag, and it does take some time to see results. So we've discussed 4 potential nutrient remediation solutions today, but I'm sure the big question is which solution is best for your water body. And unfortunately, that question has a very complicated answer. Every water body is different. We would need to know about what the water use is. What are the goals for the water body? What is the budget of the stakeholder? We would need to do a water body evaluation and look at the watershed characteristics. We would need to do some preliminary water quality testing. We need to know what the baseline conditions are, and we need to figure out what exactly needs to be improved. Nutrient remediation doesn't have a one-size-fits-all solution, so it really is site-specific, and we can't make educated recommendations without having a lot of background information. Also, these solutions are generally used in conjunction with each other. So we use them together as part of an integrated management plan. And I'm going to turn it over to Jen, and she's going to talk more about that.
All right, thank you so much, both of you. So yeah, so basically, you know, what Shannon said, there's not one size fits all. There's not going to be one solution that's going to fix all of your problems. You can see just with nutrient remediation, there's 4 different ways. So there's also different ways to manage your water body as a whole. So we recommend an integrated management plan. So what does that look like? You know, usually it's going to be a mix of both natural solutions and chemical solutions. Generally, you know, there's ongoing maintenance programs. You can see on the slide here, we have 3 different levels, premium, plus, and essential. It's very customizable. There's add-ons, so we can really work with you to determine the best fit for you. But you'll notice with all 3, there's some kind of water quality testing, which is so important, whether it's once a year, quarterly, so that way we can kind of figure out what your issues are, and then look at what type of program is going to work best for you. Again, you know, definitely not cookie cutter. All ponds and lakes are different. Even the size and shape of them goes into how we figure out the best way to manage this. So hopefully today's presentation was really informative for everyone. We're going to get to the questions here in a second, but really quickly, I wanted to let everyone know there is going to be a feedback survey at the end, so you can request a consultation at that time as well. If you don't have time to stay on, or you already know you want a consultation, we're going to go ahead and put a poll up here in just a second, so you can go ahead and answer that. And then one of the survey participants is going to win a Solitude swag bag. So definitely take those surveys. We really appreciate those. So we'll let those who want to request a consultation do that now. And then I'm going to go ahead and look at the questions that we've gotten so far. Looks like we have quite a bit. So we'll try to get to all of them. So we'll let the other 2 come back on. But for right now, the first question we have is Jill from Texas. She is asking which nutrient remediation solution is best for restoring reservoirs that have excess nutrients and algal blooms. So I'm going to let Dominic take that one.
Great, that's a great question. You know, both products are certified by the NSF to be used in drinking water, so there's not necessarily one product over the other that would be best. We've treated drinking water reservoirs with alum up here in the Northeast, and I'm sure there's been some Foslock treatments as well in other parts of the country. So it's really depending on your individual reservoir and the specific needs for that, and what the nutrient conditions are, what the flow is. I mean, there's many factors that could go into that would really should be kind of planned out ahead of time.
Okay, that was a great answer. We'll move on to the next question, which is from Kevin in New York. He's asking, how can I determine whether a lake is a good candidate for mechanical harvesting, and how do I go about building a management program? So I'll go ahead and take this one. So with mechanical harvesting, there's a lot of different things to consider, of course. The type of plant that you're trying to remove, what the growing season is, what access looks like for the equipment, what you're going to do with the plant material when it's harvested. So definitely would recommend calling an expert to come out and kind of look at what you have, make sure it is a good fit for you. And then as far as building a management program, you know, really the same situation. You've got your size of the pond or lake to consider, your budget, your goals. So really just depending on what you want to do and what the issues are, would really recommend a site visit, again, by an expert to help you build what that looks like for you. And so let's see, we've got next question, Ronnie from North Carolina. How do oxygen levels in the water column affect algae growth? And I'm going to give that one to Shannon.
Okay, thanks, Jen. So yeah, Ronnie, that's a good question. Oxygen and algae blooms are related to one another. We talked about that compost pile on the bottom of the pond that can feed nutrients into the water column. And, you know, most of the time during the summer months, ponds can become stratified, and that water towards that, the water sediment interface becomes devoid or low in oxygen. And that actually promotes chemical reactions that favor the formation of those compounds that are biologically available nutrients. So when you have higher dissolved oxygen levels throughout the water column, that tends to lessen the amount of those available nutrients. Again, though, you know, we wouldn't want to consider aeration to be a treatment for algae. You would look at it more as a water quality improvement strategy.
All right, thank you, Shannon. Let's see what we have next. Tommy in Florida. He wants to know, can Solitude help groups with grant money applications from the state? I'm going to give this to Dominic.
So yeah, the answer is yes. We're happy to help with that. We've actually, a number of our projects have been funded partially through state grant applications and even federal clean water grant funding as well. So you know, we're happy to provide some of the details, help out with that, and provide any data or any other information that you might need to complete those applications.
Oh, that's awesome. Hopefully some people can get some help. Okay, so let's see. The next question we have is Maria from New York. She wants to know, what is the best strategy to control invasive plants like water shield and milfoil? And I am going to let Shannon take this one.
Okay, thanks, Maria. So vegetation management is a very separate discussion from nutrient management. Again, you know, if you have a nuisance vegetation issue, nutrient management is not going to be the first line of defense or the first prescription for that type of problem. When we look at nuisance vegetation issues, you know, again, we need site-specific information, you know, what species we're dealing with, how much coverage there is, whether there are any beneficial species that need to be avoided, the size of the water body, the depth of the water body. Again, budget really comes into play there. That is a huge piece of vegetation management practices. And then also, you know, where you are in the world. I know specifically New York can be very difficult for permitting to get any type of management program established, especially with herbicides. But, you know, the management strategies that we would look at might be an herbicide program or some type of mechanical harvesting program, or even in some areas of the country, triploid grass carp in certain instances can be effective. So again, it's a you know, no one size fits all solution, but we wouldn't look at nutrient management as the first consideration. Okay.
Thank you, Shannon. I think that was a good start. Everybody's got invasive plants, right? All right, so the next question is from David in Missouri. He wants to know, what is the best way to keep nutrient levels in check? I'll go ahead and take this one since he's in Missouri. So hi, David. So really the best way to keep nutrient levels in check is to know what those nutrient levels are. You know, ongoing water quality monitoring, whether that's once a year or if you can do more than once a year, that's really helpful just to understand what those levels are and if action needs to be taken. There are some things you can do, like putting in, you know, plants around the pond to help incoming nutrients, besides what we talked about today, which is more for, you know, the in-pond nutrients, but you know, just looking at the sources of those nutrients as well would be what we would recommend. Let's see. Next is Sarah from New Hampshire. So she wants to know, we know establishing a beneficial buffer, which is what I just mentioned, can help reduce nutrients from entering your water body. What are the best plants to plant around your shoreline? And I know Shannon does a lot of planting projects, so I'm going to give this one to her.
Okay, yeah, as Jen mentioned, beneficial buffers, we definitely recommend that practice. They have so many benefits, not just nutrient filtration, but they also help to stabilize the shoreline. They provide habitat for beneficial wildlife. In my opinion, they look better than a pond that is manicured down to the edge, although I guess that is personal opinion there. But as far as what to plant, I guess there's a few different ways to get a buffer established. The simplest way is just to let what is already naturally growing there come up and stop mowing all the way to the edge and see what you have. It might just be weeds, but you know, maybe there are some beneficial plants that are already growing there. Or you know, you could actually do a planting plan and plant some vegetation either in the water, some aquatic plants like you can see in the slide here. Some pickerel weed is in the forefront of the picture there. And then also you could plant some terrestrial plants up on the edge of the shoreline. And I guess the best recommendation about what to plant would be to focus on native plants, which again can vary depending on where you are in the country, but you want to stick with native vegetation because not only is it the most suited to the weather conditions in your area, but it also is going to provide the best habitat for the wildlife that's native to your area.
Yeah, that was a really good answer. I know we did a couple of planting projects out in Missouri this summer, and besides being great for a beneficial buffer, the habitat as well for your fish. So that's another added benefit. Let's see. The next question we have is Kevin from New Jersey. I think you might have touched on this, but he wants to know when is it best to treat with algicide when you're using a phosphate binder like alum? So Dom,
Yeah,
I'll let you answer that.
Thanks. So treating with an algicide is typically going to occur when you're starting to get a bloom. So it's a reactive approach, but it's necessary. You know, algae blooms can impart taste and odor. If you're a drinking water reservoir, they can be potentially hazardous in terms of algae toxins if it's a cyanobacteria or blue-green algae bloom. So the best time to do an algicide treatment is really very early on in the bloom, at the first stages of the bloom. So that kind of underlines the importance of having a robust algae monitoring program. So regularly monitoring that so you can catch that bloom as it's starting is really the best time to do that. Once the bloom gets going, gets severe, it gets much more difficult to treat that effectively, and often takes multiple treatments in a longer period of time. So early treatments can nip those the blooms in the bud and really reduce the amount of treatments that need to be done. In terms of phosphate binders, so once you've kind of studied your lake, your nutrient levels, maybe even done a nutrient budget for your lake where you see how much nutrients are coming from the watershed versus the sediment. Once you've decided that a phosphate binder like alum is appropriate, really the best time to do that is probably the spring. So the springtime's better. So we don't have any algae blooms usually, which may interfere with the alum treatment. Also, all of that phosphorus is typically going to be in a dissolved form. You know, all the more complex phosphorus, like that's comprised in algae biomass, is generally going to be settled out to the bottom of the reservoir or ponds from the previous fall. So the spring tends to be the best time. Fall is the second best time. You know, usually after, up here in the Northeast anyways, after Labor Day. That's good too. Can sometimes take a little bit longer to work because you may still have some of those decomposing nutrients from weeds and algae occurring. In the southern parts of the country, obviously your growing seasons are much longer. You're not going to necessarily have a time where you may not have an algae bloom. So once you've decided that you want to do phosphorus treatment, you may, if you're having a bloom currently, you may need to consider doing a pre-treatment with an algicide in order to knock the blooms down. But I think the key here is, you know, obviously nutrient mitigation is proactive, algicides are reactive. Ideally, we'd all be doing our best to try to use a proactive approach and kind of minimize the needs to do those algicide treatments.
Oh, thank you. That was really informative. Let's see what we have next. Okay, so we have Meredith from Florida. She wants to know, what are the worst offenders affecting the balance of pond nutrients? And I'm going to let Shannon take this one.
Okay. So that's kind of a hard question to answer without sounding a little bit sarcastic, I guess, because the worst offender creating a nutrient imbalance would be whatever is doing it in your water body. So it could be the flock of 1,000 geese that are, you know, always hanging out around the pond, or it could be your neighbor that is, you know, wants a really green lawn and isn't using fertilizer responsibly, or it could be the construction site upstream that is, you know, maybe causing sediment to wash into your water body. So, you know, really the important thing is, and I think Jen touched on this earlier, to really determine what the source of nutrients are in your particular water body. And we do lake and watershed studies for that very purpose, to figure out, you know, where are the nutrient issues coming from. Sometimes it might be mostly external sources. In a lot of cases, it could also be a lot of internal loading from that, you know, release and recycling of nutrients from the sediment. So, you know, there's a lot of different contributing factors, but again, you know, every pond is going to have a, you know, a different answer to that question.
Yeah, no, that definitely makes sense. I know, you know, a lot of times we look at the surrounding areas and, you know, there's a cornfield nearby, you know, or something like that too. So very, very site specific. So the next question we have is also from Florida, Carol. She's asking, how can you best protect your lake or pond in the future from water quality issues? So I'll go ahead and take this one. Thank you for writing in, Carol. So I would say, you know, to protect from future water quality issues, you know, reiterating what we've talked about, it's proactive management. You want to make sure that you're monitoring the water quality, you know, implement some kind of management program where someone's coming out and keeping an eye on things. You don't want algae or other weeds to start to take over. You know, you can use some of the applications that we talked about today for proactive management, but, you know, really the best way is to have some kind of ongoing monitoring and management plan to look at those specific issues to see what we can do to help you manage from future problems. So we'll move on to the next question. Janet from New York. Got a lot of people in New York today. Are there permitting requirements for alum and phoslock? And I'm going to give that to Dom.
So, the short answer is it really is dependent on your state. So every state handles these techniques differently. None of the products that we've talked about today are considered pesticidal. They do not have pesticide labels. They do not directly kill algae. So they're designed really for water quality improvement, phosphorus binding. But they're definitely, you want to check with each state. Some of the states up in New England do kind of incorporate the use of some of these products into their permitting programs. So it's important that whatever state that you're in, and we can obviously help you with that. Our regional teams are familiar with the permitting requirements for these products, so we'll be able to put you in the right direction and let you know what's needed. But ultimately, it'll vary depending on the state that you are living in.
Thank you. Yeah, I know that's definitely true. I know a lot of the northern states have more strict permitting requirements, at least in my experience. Let's see what we have next. We still have a little bit of time here. So Wilhelm from New York again, asking what solutions would you recommend for a lake with low dissolved oxygen levels? And I'm going to pass that one over to Shannon.
Okay, thanks. Starting to feel like there's a bit of an echo in here because it kind of depends on your specific water body. There's a lot of factors that go into designing an oxygenation or aeration strategy. We need to look at the, how low is the dissolved oxygen? What is the cycle throughout the year of what the dissolved oxygen does? Is it stratified? How low does it get? What is the depth of the water body? That plays a big factor into it because a lot of the strategies for oxygenation are dependent on the volume of the water body. And, for instance, diffused air systems work better in deep water, but in a really shallow water body, that wouldn't be a very effective strategy. We also have surface aerators like the fountain shown in this slide here. In shallow water bodies that are kind of small and uniform, maybe a surface aerator might be adequate for providing, some oxygen benefits. And, we also have the new oxygen saturation technology, which is a direct oxygenation technology. So it really depends. I guess you said lake in your question, so I'm assuming it's probably a larger water body. So you're probably going to be looking at a diffused air system, would maybe be the most cost effective, but again, without more details, it's really hard to give a specific answer.
Yeah, no, I definitely agree. There's a lot that goes into play with that stuff. So thank you, Shannon. Let's see what we have next here. Dawn from Virginia. So she is asking, are these solutions safe for fish and other aquatic life? And then also, is it safe to swim in the water after an application? So I'm going to give that one over to Dominic to answer.
Great. Well, thanks for the question, Don. That's a great question. I'm sure it's on a lot of people's minds. So the answer is yes. With a caveat, when these products are applied properly, that they are safe for fish and aquatic life. So that means properly dosing, properly applying. It's important to have a professional applicator do these types of treatments, a professional, so that we make sure that it's done properly. Because if it's not, there would obviously be a potential for that. I'll talk a little bit specifically about alum. As we mentioned in the presentation, alum can have an effect on pH. So it's also very important to monitor and kind of manage the pH changes during an alum treatment, using that buffer ratio and making sure the ratio is right. If the pH goes outside of that desirable range for alum, there is some potential fish toxicity. So it just underlies the importance again of having a professional do the work. So we know how to keep that pH stable. We know the right ratios. We can monitor the pH and really respond to any changes in on-the-spot data to make sure that stays in the proper range. In terms of swimming, so again, there's no specific swimming restriction on treatments that we've done in the past with alum and Foslock. We've asked folks to stay out of the water, or at least stay out of the water in that whatever specific area we're treating for that day. But they've been allowed to go back into the water in the evenings. If we're not working over the weekend, they can go back and use the water over the weekend. But generally, the Foslock and the alum settle out within a matter of hours, and it's perfectly fine to go swimming after the applications are completed. We often allow boating, fishing to happen right along, just kind of posting notes asking people to stay away from the treatment equipment. But overall, very limited impacts on recreation, and still be able to use the lake as normal.
All right, thank you so much. So let's see, we got a couple minutes left, so we'll get to, I think we have time for 2 more questions. We have Catherine from Florida. Are there any pond bank erosion repair solutions for water bodies that want to establish a buffer, but the shoreline is too damaged? And yes, actually there is. So we actually have what's called SOX, S-O-X. It's a erosion control method to create a bioengineered shoreline, which basically, if you have a lot of erosion, we can rebuild that shoreline. We use a type of mesh material, kind of taco it in, so if you can imagine that, and then fill it usually with local fill material, and then you can actually either sod over that, you can seed it, or we have a lot of people that will plant, which you can plant native plant species right into that material. So then you can create any beneficial buffer that you want after you've repaired the shoreline. So hopefully that answered your question. If you want to learn more about that, I would recommend reaching out to us. And then we're going to do one more question here, coming from Cindy, and she is asking, which is a really good question, why would someone choose Foslock over alum? And I am going to give that one back to Dominic.
Yeah, that's actually a great question. So there's probably a couple factors involved. One of them is there can be a significant cost difference between Foslock and alum. So that certainly would play a role in that. Other than that, I mean, the products work fairly similarly. I think some of the other factors that may come into play would be, I know some parts of the country, you may have some very state or regional specific aluminum criteria for like discharges from lakes and ponds or drinking water reservoirs. There may be very specific aluminum specifications for the finished water, so that may play a role there as well. Just ambient water quality in certain parts of the country may favor Foslock or alum over one or the other. So I think those are really part of it. I think maybe one other thing that I know some parts of the country it's maybe hard to get, not so much the alum, but some of the buffer solution like sodium aluminate's a little less common. So depending on where you are, you may find it economically difficult to get buffer solution there, in a timely fashion or within your budget. So that could play a role as well.
Okay, yeah, no, that definitely makes sense. Well, I appreciate you guys answering the questions for us. Looks like we're a little bit over, so thank you very much for staying on if you're still here. So we definitely weren't able to get to the questions. I'm still looking at a decent list here. So we're going to go ahead and plan to get those answered. We'll have a second Q&A session very soon, and we'll get those emailed out to everyone that attended. Again, just thank you so much for coming. Hopefully, this really helped everyone, and we hope to hear from some of you very soon.